Hello YouTube world, this is Logic Crazy, and here's another tutorial on creating a Java chess engine. I figured in this tutorial and perhaps in the next few we will take a break a little bit from the actual engine part and figure out just some very basic of connecting this engine, which comes up with a move, and turn it into something which can produce a graphics component. What I'm talking about is right now you're pretty much getting a command prompt output here with these R's and K's and stuff, and it works pretty decently in many regards, but I would like to click and drag to make my move. I want to drag this pawn up to or something, and then let the computer make a response move and so on. So let's work a little bit with this. It's been a while since we worked on graphics. The first thing we'll do is get rid of this commented area here. Now there'll be a few errors. So that's this whole J-frame thing. And if we uncomment this import, we're now back to everything's green over here. So let's run this. If you recall, hopefully this works. There we go. We get a graphics. And remember, we're moving around the square and a word and revealing a different portion of the circle based on horizontal. There's also some transparency. I do want to fix that transparency. I believe the graphics you have will be better. Let me do this, copy and replace. There. That was a graphics that purposely had transparent. Now when you go over there, white queen and white king aren't transparent and such. Okay. So let's modify this. This was not a very chess-like graphics interface. And the whole drawing thing is drawing all of this right there. So, well, we can put this all in comments for now, just in case you want to use something similar to what those examples had been. But we want to make a checkered square. Now, checkered squares, there's a few rules in chess about this checkered squares, and that's obviously it's a full checker, but which corner gets a darker and which one gets a lighter square. So we'll worry about that, but let's not worry about that for now. Let's first figure out how to make a checkered pattern. And so the way we'll go about this is we'll have a for loop. For int I equals 0 and I is less than 64 and I plus equals 2 we're going to go with. Now, I'll explain why this is. Because basically, here, if I open up Arena here, you're going to see the way this works. So you have the, obviously, light colors in the top left, top right, or bottom right, top left, and so on. So always for the person sitting down, the bottom right corner is where their rook is a white piece for both sides from their perspective. And what we want to do is I'll have a function that'll draw a light one followed by a dark one, and then it'll jump over to light, dark, and then 2 light, dark. So instead of doing a light and then dark, light, dark, I'm doing it in pairs of 2. That's why I have plus equals 2 for the I. So we'll first set the color to the first one. Feel free to change these colors or use images, which I have shown you down here using chess images. You can figure that out on your own if you want a wood grain or something. But g.set set color. There we go. And we're going to have a custom color as new color And let's make this, this is an RGB, by the way. So red, green, blue. Scale of 255 to 0. So we'll say 255, 200, and 100, I believe is what works. And then we will draw that square, and then we'll have another one. And I'll just copy this. And this will be the other square, so the darker square. At, let's see, 150, followed by 50, followed by, let's make it 30. You might not like these colors, but I think they're close enough. All right, and now we'll do G dot fill rectangle. And before we do this, I want to declare a few statics besides this. I don't even think we need these. Let's see what happens if I get rid of them. Oh, there's a bunch of dependencies on this thing. Okay, I'm leaving them there. Static int, and let's do, let's see. I'm actually going to leave this. I was going to have a border around everything, but I think I'm going to leave this for now. Just to make it simpler, we're going to put in, we will do a square size. Int dot, let's see, yeah. We'll leave it as square size. And we're going to set that to 32 pixels for now. And what I'm meaning by square size is, for instance, this. The square size, let's say, on this one was 32. But when you resize the window, you can see how the square size all of a sudden got down to maybe a value of 5 or something. And so we'll be able to expand and shrink this thing uniformly when we expand and shrink the window later on. So that's why I want a square size. Now, what's the X position on this thing? And here's the values. It is X, Y, and that's by doing control space, by the way, X, Y, width and height. And width and height are both square size, obviously. So I put that there, and the one there. Now, as for this, we have, it'll be I divided by 8 plus, in brackets, I modulus 8 and end bracket modulus 2. And this modulus 2 will do this every second dealy kind of thing. And then that times, I think I can just paste square size. Now I'm just going to copy this. It's not the same for Y, but it's close. It's just I divided by 8 times square size. This whole extra part here is what does this whole every second one kind of deal. This one here is, oh, and I should mention, it's not as simple as every second, and that's why I'm adding this. If this seems like it's unnecessary, that the second rectangle should just be one further than I, so I plus 1 over. This one's just I over. The reason is this, for instance, this row starts with a dark, this row starts with a white, and they alternate what it starts with, and that's what this percentage 2, modulus 2 does, is it switches it every second row. Okay, anyway, and now this next one, we're going to switch it and put in a bracket and say I plus 1. And then I believe, let's see, running through some math here, modulus 8. And then I'll do minus, 2 brackets, I plus 1 again, and then divided by 8. Whoops, not 80. That'll have some disastrous results. And then modulus 2 again. Let's see what happens. No idea what will happen. And what do we get? Oh, we get something. We're getting something interesting. Now, why am I getting 3 colors? Let me just delete this whole part here. Run it. Now I get no colors. And then when I put this in, it only really switches between 2 colors. But it ends up with 3. Very intriguing as to why that is. And it looks like it starts with a good pattern and then it turns nasty. Alright. Let me just run through what I'm doing here. I'm setting the color, filling the rectangle. That would be a mistake. I believe this should be a modulus and this should be a divided by. I'm going to say. Oh, that's another area I made a mistake on. Modulus and divided by. Oh, and this is not a 1. This is an I. Another mistake there. And what about this one? Oh, I did plus 10. Big mistake there. And then over here, I should have had one other thing here. Put another bracket there. It's still, except now it's I plus 1. That's what works for this. And then divided by 8. End bracket. Alright, let's try running that. What happens? There we go. A perfect job there. That is exactly what it should be. The light colors in these corners, dark ones in that corner. And feel free to look through the math. I didn't really explain it. I was just running through it in my own head. But run through the math, figure out why that makes it checkered and why you can do this. And if you know a simpler way, please drop me a comment. So that's the first things with graphics. But we need to go a little more complicated than that. And that is we need, we first need to figure out a way that we can put pieces on here. So based on this, this chessboard here, based on what this is, I want to just draw the right pieces at the right place based on this chess pieces PNG. So if we copy these last 3 lines, good thing I just commented them. Oops. Yes, I'll cut them actually. There we go. Create an image there. Now let's see. Just trying to think of the best way to do this here. All right. All right. Let's make a yes. Let's make a for loop here. A for, and I equals 0. I is less than 64. I plus plus. Lowercase I. There we go. So this will go through each square. And then we'll also create int j equals -1, comma k equals -1 as well. Alright, and I'll explain what these are for later. And now we will create a switch statement. Let me see. I'm not sure if... okay, we do have a switch statement. Switch statements aren't the easiest to write out from scratch, so I'm just going to copy a switch statement pop that in there. So I have discussed switch statements already. Now, of course, we need to change this. For instance, this chessboard is wrong. How do we refer to another class's static variables? Well, what we do is we say alpha, well, whatever the name of this other class is. In this case, alpha beta chess dot, and then you get everything that was in that class. So it's referencing to this class here. Okay. So based on whatever this is, so if it's a capital P, do this. If it's a this, do this. So we'll start out with it if it's a capital P. Now, we're basing it off of this image. And maybe I'll put this image there on the side just so you can see it. Let's see. All right. Maybe I can open it with something else. Just make it smaller. There we go. Okay. Now, what we need to do is we're going to basically, after we set our J and K are going to be the coordinates that are we're going to grab a portion of this image. And if it's a rook, a white rook, we want to start at this coordinate and go 32 over, 32 down. If it's a black bishop, we want to start at this spot and go 32 over, 32 down, or whatever. That's what happens to be the size of these images. They're each all about 32, squares of 32. So that's what these J and K are for, and that's what this is for. It's to set what J and K turn into. And I just start them both at -1. And what we'll do is we'll say if after this thing, if they're both -1 still, then we know that that spot's an empty spot and not to draw anything. So let's record these as follows. So J equals 5. Now that's for a capital P. So this is a white pawn. So basically 1, 2, 3, 4, 5. We start right here. So 0, 1, 2, 3, 4. It's the fifth item, you could think of it as. And then K equals, let's see, K equals 1. We'll set it to 0. We'll have to change a couple of these things later as we get more complicated. J equals 0, or K equals 0, sorry. And then we need a new case. Whoops. A new case for a lowercase p. And in the lowercase p, the only difference is this turns into a 1. So, the same goes for the rook. I'm going to copy this, paste it in there. Copy this. So here we have capital rook would be 2 over 0, 1, 2. Now we have our knight and our lowercase knight. Let's change all of these cases. Bishop, lowercase bishop. Queen. Lowercase queen. And king, lowercase king. You probably beat me to this. I'm a little slow at it, but at least I got it done. Now, you can probably figure out what these knights should be. They should be at a position of 4. 4 and 4. And obviously the second one you always turn into a 1. I should have done that with the rooks. Believe this should work. A little bit of a gamble here. Let's see. Now, as for bishops, we have a value of 3, 3 and 0, 3 and 1. Queens are a value of 1 and 0, 1 and 1, and kings, of course, 0, 0, and 0, 1. There might be an easier way of doing this, but this is how I think of. I must say that I'm not a genius at all these graphic things. That's not my area of expertise, but I do know the basics of how stuff works. So now we need this. So now that we've set where J and K are relative to the picture, we need an if statement. Remember, we have to make sure that J does not equal -1. You could put an and or an or statement. I'll stick with an and K does not equal -1. So that would mean if it's an empty spot, and if it is, just jump over that square and not write anything. Now let's grab this g.draw image right there and paste it in, make a few modifications to this. Let's see. Chess piece image. Good. Now, this spot here is a little different. Let's see. I modulus 8, I believe. Let's try not to make too many mistakes this time. Times square size. Maybe that'll work. Let's just copy this. And then this would be I divided by 8, followed by, now, what are the parameters for this? It's x, y, width, and height. All right. Hopefully. Yes. Image, x and y. Okay, now, width and height are still dependent on square size. So, I was just thinking this through. So, it would be I modulus 8 plus 1 times square size, I believe, followed by the divided by equivalent. And let's see, got 4 more values to put in here. So this would be, this is where we start using the J. It's J times 64. And then it would be K times 64. And then, so each one of these is 64 by 64. And so on. So I have it working out very nicely for me. And we'll see if I'm right in a second. J plus 1 times 64. And K plus 1 times 64. Now, not sure if this will work. Let's see what happens. Aha, look at that. And looks like a piece moved, which is excellent. Fascinating. Notice it all of a sudden you saw a bunch of pieces moving randomly around. That was the alpha beta running through a whack of ideas. And then finally this piece popped up. So obviously we're somehow calling alpha beta. Oh yes, alpha beta is being called from the alpha beta chess class. So that is all for this tutorial. You have now created visually looks good. Now, next time we'll have to learn out how to make a drag move and interpret that into a move format, as in row, column, piece captured kind of thing, and then get it to make a response move. So until next time, enjoy Java.